Hi everyone, welcome from the Smithsonian Air and Space Museum. I'm Eric Fanning, Secretary of the Army, and I'm with NASA astronaut and West Point grad, former Army Colonel Tim Kopra, who just returned from the space station. Here with me today to walk me through the museum and discuss a few aspects of his life in space. Tim, welcome.
It's great to be here. Thank you so much.
Where are we now?
So this is actually a mock-up of the space shuttle. Now we have the International Space Station, but there's still some aspects of life in space that are represented here. We exercise about 2.5 hours a day, and so it's very important to maintain our bone density and muscle mass. We sleep on the wall. We take a sleeping bag and we strap it inside our crew quarters, and that's where we sleep at night.
That's great. So is it 2.5 hours on a bike similar to this, or different other ways that you exercise?
It's a little bit different. So we have a bicycle that has to be isolated away from space station because you don't want to impart loads on it. So we have a bicycle that's similar. We'll spend about 30 minutes doing aerobic exercise. We also have a treadmill, ironically, and we strap ourselves down to the treadmill and able to run. We also have a weightlifting machine, and it feels just like lifting weights, like doing bench press or deadlifts or squats. And also isolated from stations so we don't impart loads, but we come back pretty strong.
Can you tell me a little about these cameras here? I see a rather big one there.
You know, this is very old school. This looks like an old IMAX camera. You know, these days, because of technology, we really don't have to worry about film, and so we can take as many pictures as we want, and we just downlink those pictures, and it's a great way for us to be able to share the experience.
That's good. I know we all love them. Right out here, we have a model. Smithsonian has a model of the space station. I would have thought it looked bigger next to the space shuttle. But can you tell me a little bit about it? Where you live, what the different compartments are?
It's an amazing vehicle. If you look at this, the long piece that goes this direction is the backbone of space station. It's external and it has all the different components that we need outside. So for example, it has the components that allow us to move the solar rays. We have 8 solar rays, 4 on this side, 4 on the other side, and they can always orient directly into the sun to maximize that sun angle. We have radiators that point out to the back because the balance of equations for heat is that you have too much heat on board, and so we take heat from inside our living volumes, we transfer it outside. And then all these little canisters is our home in space, and it's made up of a variety of different laboratories. There's a European Space Agency one, Japanese, US, and Russian segment. And then you have a robotic arm on the front, and that robotic arm, along with spacewalkers, helped build this space station.
How long did it take to build this?
We started actually back in the 80s with designs, but the first component launched in 1998. We finished about 2011.
Do you know how many loads it took to get all that up there?
Oh goodness, I think it was about 42. It was several different loads. So all these components, with the exception of just a few that went up on Russian rockets, had to fit in the back of the payload bay of the space shuttle.
So how many days have you spent up there?
I've spent 244 days total on the space station.
That was 2 missions?
2 missions.
And how'd you get up and back?
First time I went up on a Space Shuttle Endeavour, and then they went home. I stayed for about 2 months, and then I came home on Discovery. This last time I launched out of Baikonur Cosmodrome in Kazakhstan on a Russian rocket and spaceship.
Now, this is obviously a lot bigger than the space shuttle.
It's a lot bigger than the space shuttle.
So how is life different on the space station?
You know, life is really incredible because it may look like it's confined, but you never have that feeling that you're confined. There's just a lot of volume. And the windows are amazing looking down on our planet, and we have all these different experiments going on, so we're gainfully employed every day.
That's great. Can you tell me a little bit about this glove that you brought with you?
Yeah, this glove is very similar to the training gloves we use. In fact, it's an older glove. We have a newer version, but basically, when you're out in space on a spacewalk, it's a lot of work because you're in a vacuum and there's 4.2 psi of pressure, and so you're always fighting against that pressure. But it's necessary for us to be able to protect the human body in space. We have a pure oxygen environment, and we're working really hard to do the different tasks that we have.
So how's the new glove different from this one?
It has just a different lining on it. It's a different protection system because when you're out in space, if there's any sort of rough parts, you can actually tear the glove. You don't want to tear your glove because it's pressurized. And so the fit is a little bit tighter too. You want the glove to really be conformal to your hand because your hands are just so vital on a spacewalk.
Otherwise you're going to be like Matt Damon in The Martian.
Yeah, exactly.
Yeah. That's great. Well, we can walk over here. They've got an example of the space suit that I know you used when you did your walks. How many hours were you out on spacewalks?
So a total of a little over 13 hours on spacewalks.
What was the longest one?
Longest one was about 5.5 hours. Yeah, sometimes they go about 6.5. These are a little bit shorter. But it's an amazing system. It's like a spaceship because everything you have is right here. You wear a cooling garment, and so you can control cold water going through your system. If you get warm or cold, you can adjust it. It has your oxygen, and it's what you are able to use outside in space. And it's it's pretty mobile. It's you still have to work through it. These joints can move, and you have to work in a certain angle in order to get those arms to move around correctly. But it works really well.
How much does this weigh on the ground here?
It's about 250 pounds, so it's pretty heavy.
How long did it take you to suit up before you go outside?
It takes a while, and it's not simply just putting on the suit, but we have this regimen that we go through because we have to purge the nitrogen from our body so you don't get the bends, and that procedure just takes a long time. And we have to go through a series of changes in pressure inside our airlock, and so it takes a few hours actually before you can go outside.
What about when you come back in?
When you come back in, it's pretty quick. You come back in the hatch, you close the hatch, you repressurize the smaller volume, and within a few minutes you can open the hatch, and your buddies are taking off your helmet and gloves.
Pretty good. Now there was a sign on this earlier when we came in saying not to touch the visor.
Yeah.
Why is that?
Well, this coating right here, it's gold coating, and you could easily scratch it. So I think we want to protect it.
Yeah. What was the most uncomfortable thing about wearing this?
You use your hands so much that your hands get a little bit bruised and a little bit worn out over time. I think that's probably the one area that people end up getting the most use.
Is that the factor that limits the amount of time you spend out there?
No, really, it's really the consumption. You have your oxygen system on board. You can actually go back into the airlock and you can charge up oxygen pretty quickly, but you also have a canister that scrubs out the CO2, the carbon dioxide, and oftentimes that's the limiting feature.
So what's it like?
Unbelievable. The first time you open a hatch and you look at the planet going 5 miles a second below you, it's pretty eye-opening. But then you get to work, and we're very well trained. We have a training facility called the Neutral Buoyancy Lab at Johnson Space Center, 40 feet deep, 200 feet long, 100 feet wide, and it has a mock-up of the space station. And so by the time you're well trained through the Neutral Buoyancy Lab, you really feel prepared to go outside. But it really doesn't prepare you for the view that you have. It's just amazing.
Different even than inside the space.
Even as inside. When you look through a window, you think, hey, I'm kind of seeing the whole planet. But when you're outside completely and your entire visual field is the Earth, it's really astounding.
Now, are you out there on your own, or are you with someone else?
We always go out in twos. And so I was out on my first spacewalk this trip with Scott Kelly, and the second time with Tim Peake.
What were you working on?
The first time was a pretty quick turn. We arrived on a Tuesday. We found out Thursday night we needed to do a spacewalk to fix a cart that had gotten stuck in place, and went out Monday morning. So a pretty quick turn. After 6 days on space station, we did a spacewalk. The next time we had to replace a sequential shunt unit, essentially a big circuit breaker that would stop the charging of the batteries, and that had to be changed out. Interesting time, because it had to be changed out when it was dark. We got there 20 minutes early, and we could just hang out and take pictures for about 20 minutes.
All right, I think we have some questions from our feed.
Sure, we have a question. This person asks, how would a new Army recruit put him or herself on a path towards becoming an astronaut?
That's a great question. In order to become an astronaut as an Army person, I think it's very important to have a very strong operational and technical background. And like any career field, you have to be the absolute best that you can be in order to sort of rise to the top. And I would recommend that path.
Another question?
Sure, this one's from Joanne. She's asking, do you sweat a lot in the spacesuit?
You can sweat a lot in the spacesuit, and as we were discussing before, you can control the temperature. So you actually don't want to get too cold because it's really hard to warm up again, but you can control that through that essentially that thermostat control.
Thanks. Can you tell us a little bit what's behind you over here?
Yeah, so this is a Sokol suit. This is the spacesuit that we wore inside the Soyuz that we launched out of Baikonur with. And so this is a pressure suit that can take you up to 100,000 feet, and it's what protects you inside the Soyuz. So, nominally, you really don't need a suit in a Soyuz because you're in a pressurized environment for the most part. But if you have any sort of off-nominal situation, you need to make sure that you can still breathe and maintain that environment. So it protects you inside the Soyuz.
Great. I think we have a rocket engine over here we want to get your thoughts on. Look familiar to you?
It does look familiar. It's big.
Hi. Welcome. It's great to see you. Thank you for coming. So let me tell, welcome to the Air and Space Museum. Let me tell you a little bit about this. This is the Space Shuttle main engine. only reusable, fully reusable rocket engine that NASA has ever flown. All the rocket engines before that were just single use. Very technologically sophisticated. It's not the highest thrust rocket engine. That's reserved for the first stage of the Saturn V rocket, but it is the most burned fuel most efficiently. And I always like to use for an analogy for that. If you think of looking at pictures of the Saturn V taking off, it kind of lumbers off the launch pad very slowly. Boy, when that shuttle goes, it goes up very, very fast. What's particularly interesting, I think, about this engine too, is that it has components from a bunch of different missions on it. So you'll find components from STS-1, STS-35, and that's typical of a reusable rocket engine. And one of the things I like to say about this too is that rocket engine technology hasn't changed much in the past 50 or 60 years. It's still very much the same, and it can all be traced back to the Army's early innovations in rocket propulsion technology with the Redstone. The first operational ballistic missile carried Alan Shepard into space in 1961. And this engine, I think, is also very significant because it points to the future. It's going to be the propulsion system for the SLS for deep space missions. So it's one of the jewels, I think, here at the museum, and I'm very proud to have it in my collection. So awesome. It's great.
How will that SLS engine be different from its?
Well, it's pretty much going to be the same in terms of the guts of the technology. I'll just mention one thing that's interesting about that is that when we got the shuttle Discovery from NASA after the program ended, if you look at the Discovery, it looks like the engines are there. We've got the bells, but there's nothing behind them because NASA pulled those engines out specifically for that purpose to go into the next generation launch vehicle.
That's great. Thank you. Any more questions from our Facebook feed?
Yes, we do. This person's asking, what got you interested in the Army as opposed to other branches?
You know, when I was 17 years old, I got a flyer in the mail that was talking about West Point, and something about the tradition and the quality of education and the leadership training that you get at West Point really appealed to me, and I'm very grateful that I had that experience.
What are some of the other things from your Army career that you prepared you to be an astronaut?
You know, one of the most important things, in addition to being technically proficient and having some operational skills as an astronaut, is being able to get along with other people. It's really about teamwork, and so space is 100% a team sport. And one thing you do learn in the Army is how to work as part of a team, either as a follower or as a leader. And I think that's the one thing that I got from most of the Army.
Did the Army make it easy for you when you decided you wanted to be an astronaut?
Did they make it easy?
Yeah.
In what respect?
Did they help you? Were there obvious paths and things that you could do that the Army teed up for you so you could make this change?
You know, the Army is a very traditional organization and has very traditional paths, but they do allow for different career paths, and I think that's a great aspect of the Army. It's not a traditional path, but there is room for doing different things.
Thank you. Any more questions we got from Facebook?
Yep.
No? All right.
Can you talk more about the history of the the rocket to Army and where that all began?
Oh, absolutely. I mean, we can trace the origins of ballistic missile technology to Werner von Braun and the Germans during World War II. And they came to the United States under Army management right after the war. And the Army really spearheaded the development of rocket propulsion technology with von Braun's group. There was already an indigenous capability here in the United States at the Jet Propulsion Laboratory. That was an Army facility established during World War II. Von Braun's group developed the rocket engine for the Redstone. And so, and that's sort of the core rocket propulsion technology, and the whole main line of American liquid fuel technology can be derived straight back to the Redstone and to that, to those early post-World War II years. And if you look at all the major milestones in that time period, the first Explorer 1 was launched on a variant of the Redstone, the Jupiter C. So there's a very rich history there, and this, I think, even here with the Space Shuttle main engine, you can trace it all the way back.
Awesome. Tom, thank you. Tom Glassman, Smithsonian Curator.
Thank you for coming. It was a great pleasure
Thanks,
to have
Tom.
you here. It's great.
So Tim, what's next for you?
It's a good question. You know, when you get back from a space flight, you're really focused on your rehab, your debrief, so we can learn from the experience, and also sharing the experience like we're doing now. And so I think after that period, I'll reassess and see what the next step is.
How long between your two missions was it when you knew you'd be going back up into space?
So I came back in 2009 and actually had a bicycle accident that prevented me from flying in 2010, 2011. And so I wasn't even sure I was going to fly again. I was offered the opportunity in 2013, and here I am now.
Yeah, when they offered you the opportunity, how did they describe it to you? Did they know it was going to be 180 plus days, or
No,
is it just a slot and you figure out the rest later?
it is completely a slot. I knew that I was going to be part of Expedition 46 and 47, and it really depends on how the timing works out. Typically, they go from about 120 days up to 200 days, so you have to be prepared for either extreme.
When do you think we'll break the next space duration record for the United States?
I think it's going to happen soon. We have Peggy Whitson going up pretty soon. She's flown multiple times, and I think, her numbers may put her over the top for a period of time. Although our Russian cosmonaut colleagues really hold the record for time to space.
What are we learning each time we keep someone in space longer? What are we learning about the effects of it?
It takes a lot of data for us to understand the effects of zero gravity on the human body. And so we're really building a database. And along with that, we're adding experiments. Like, for example, we're really understanding what happens to the eyes in zero gravity. And so every time we have this longer duration, it also means that we've been able to add new experiments and learn more.
What was your favorite experiment that you worked on in either of your missions?
Yeah, one of my favorites this last time was working in a microgravity science glove box, and we burned some material, which was pretty cool. It wasn't so much that we were burning things, but it was this coordination with the ground. We had some issues with hardware, and just being able to work closely with that ground team was really satisfying.
What, if you could change anything about your experience up there, any creature comfort you could bring, or the rhythm of your day, what would it be?
Yeah, you know what? I wish it was about a 25-hour day, because I'd like more time to take pictures.
Yeah.
Amazing.
How much time do you have for that?
You kind of squeeze it in, and so we have this program, and it shows where we are around the planet, and you're always trying to time it. I want to get a picture of the Bahamas or this city at night, and you're organizing your day so that you get that 5 minutes to go take that picture.
Are they giving you a long list of things they want pictures of as well?
They have some things that you can volunteer for, but really, when we take pictures, it's something that we elect to do.
That's great. Well, we all appreciate it.
My pleasure.
Great. Thanks very much for taking the time.
Thanks,
It's great
sir.
to meet you.
Nice to meet you as well.